Hey guys, welcome to Deep Dive Coding. Today we solve the code problem of the day, that is fraction to recurring decimal. This problem is saying that we are given two integers, that is numerator and denominator. We have to perform the addition operation. So that is the numerator divided by denominator, and we have to return the result in a string. But there is a catch that this is we have to return in the fraction. That fraction can goes may have the repeating numbers. So over here in the example number 3, there is numerator equal to 4 and denominator is 333. So there is a repeating characters of the 0, 1, 2. So we have to locate this thing and denote within the first bracket. And numerator and denominator as constant given can go negative up to the positive limit, and denominator cannot be 0. So if you look into this third example, that is 4 numerator and denominator is 333. So I draw some table to go there, the simple diagram. That result so far is now nothing is in the result, because now we are starting to divide this thing. And in the divisions, we are as the numerator is smaller than the denominator, then we are taking a point, that is decimal point, and we are over here we are simply taking on, and at the next still it is less than the denominator. So again we are taking 0 to place a 0 over here, and now it's 400 is greater than the 333. So now we perform the operations of the division, that is 33, that is go for the 1. So 0.01, and its remainder is 67, so on. Now it will perform operations accordingly, according to the divisions algorithm. But if you look into closely look that at the 4 over here, its numerator is 4, that is the result is nothing. And over here also the result numerator is 4, over here is result is 0.012. And if you again go into deeper that in the 4, you can see that result is 0.012, that is 012, and again 012 and 0. So this is repeating as the repeating the numerator. So what are the observations we can see over here? That result division result division result which repeating as repeating the numerator. So and so what we can do that before the decimal point, that is integer part. So before the decimal point, we have to do nothing. We just simply divide the simply do the integer division. So we first calculate uh, we first calculate before decimal point, and after the decimal point, we are also going to divisions one by one. But we have to track that which index that starts repeating the numerator. Like at the numerator over here, its result is nothing, but over here is result over here also that 4 is again comes. So it's repeating 0, 1, 2. So as result is repeating, so numerator is repeating. So we have to track the numerator. Take a hash map that simply do this thing, that numerator to result index mapping. We are taking index because we taking index because we insert that position in the first bracket. So and next thing is at each step of division, that is after the decimal point, we store the numerator with result index. And first of all, we find that whether it is already repeating numerator or not. Like over here we are perform two things. First, check is it already seen numerator. That means hash map of numerator is first index of first bracket, first index of repeating sequence, and current index is the last index of repeating sequence. And if it is not present, in the hash map, that means that will be the starting point. So we are simply storing that index in the hash map. So store the result index in hash map. And yeah, over here this will simple operations can do that thing. And let's discuss about the edge case. What can be the edge case? Can like one thing we have to know that numerator and denominator is maybe negative. Other thing is numerator could be 0. Okay, so now let's start the coding part. I think it's here for the uh, observations. Now let's start the coding. Okay, first of all, we have to do this thing simple first edge case that numerator can be 0. In that case, we have to return the 0 answer because numerator 0 that always be answer is 0. So we have to return that 0 as string. We have to return in a string. Okay, now let's take the result that will be the fraction we have to return. So first we handle the negative edge case, negative numbers. That means numerator is less than 0 and XOR with denominator is also less than 0. Then we have to push back the negative sign in the result. We have to push the negative sign in the result. Okay, so yeah. Over here it is saying that if the numerator is negative, that means it's true, and also the denominator is negative, all this is also true, then XOR with true and true, that will be the false, because if the both are the negative, then it will the result will be the positive. If any one of the negative and other one is positive, then in that only the result will be the negative. So that's why I place the XOR sign. And now I take the positive of both numbers. Apps. Now let's first of all do okay. First of all, do in the limit, we over here we define LL as long. So we have to take the long as LL because we simply avoid the constant that will be long of numerator and long of denominator, that is long X of denominator, and we take the both number as positive. After that we calculate the integer part, and that will be the result plus equal to two string. We have to do before appending that number, we have to convert that is a string and do simple integer division, and also calculate the remainder of it. That will be the num modulo denominator. And if remainder is already 0, that is equal to 0, then this will be the answer because it's have no decimal points, no decimal point. If it is not 0, then we have to simply push back the decimal point. That will be the point. And also take a hash map. In C++, it is unordered map. Unordered map, that will be take the long and int. You can say that name as position, and this will simply mapping of remainder to the index in the. Now we start divisions manually. That is remainder not equal to 0. We do until it's not 0. And if we found that thing that is in the hash map, that is position dot count of remainder, if we found that thing, it will, if it is found, then it will return true, otherwise it will return false. We found that this is the repeating re repeating uh, repeating sequence starts here. Okay, so result dot insert, we simply insert the first bracket, insert, that is where it we have to insert that, comma, that will be TJ at positions of remainder. This will be the this is the first index of the repeating sequence, and we have to push back this thing, and yeah, and we have to break it because this will be the answer, because we found the repeating sequence. If we did not found the repeating sequence, then we simply in this is in the hash map equal to result dot size, that will be the index, and remainder of remainder we have to multiply by 10, because as already point is given, and result plus equal to two string remainder by result plus equal to, yeah, two string of remainder denominator. And finally, we have to again calculate the remainder, that is remainder modulo equal to denom. And finally, we have to return the as an answer. Yeah, over here. Now let's try to sum for the sample test case. Yeah, it's done for the sample test case. Now discuss the time complexity of it. So if you look into this thing, that over here integer part calculation, we are simply division, we are simply divide in big of one time, and after that we are taking the unordered map, that is as map of the position, and until the remainder is 0, we are dividing, and if we found the repeating sequence, then that will be, we are simply return that answer. So in the question is given that it is guaranteed in this question over here, it is guaranteed that the length of the answer string is less than 10 to the power 4 for all given inputs. So whatever inputs is given, that answer should be max 10 to the power 4. So our iterations goes at max 10 to the power 4. So time complexity would be 1e4, that is 10 to the power 4, and we are simply storing each remainder as positions also. So it also takes the 1e4. That will be the space complexity also of the of 1e4. That will be the 10 to the power 4. Okay, so now let's try to submit this code. Let's check whether it is fast or not. And if you guys found anything helpful, feel free to comment in the comment box. Thank you guys. Thank you for watching.